Module 5 continues with Part B, Building the Alarms SQL Statement. In Part A, the alarms table was described using \d so many times. From the description, these are the fields of interest. The fields listed in black require some massaging. The alarm type is kept as an integer, but the value represents a string, such as problem, resolving, or notification. To make the display more user-friendly, an array will be used to convert the integer to a string. The node ID will be used to extract the node label from the node table. The service ID will be used to extract the service name from the service table. Sticky memo will be used to extract the sticky memo from the memos table. Recall from Part A that only one record was used to store all sticky memos associated with an alert. The reduction key will be used to extract the journal memo from the memos table. Recall from Part A that only one record was used to store the journal memo for an reduction key. The severity is kept as an integer, but the value represents a string, such as indeterminate, normal, or critical. To make the display more user-friendly, an array will be used to convert the integer to a string. As a reminder, here are the severities. The alarm table stores the codes. The preference is to display the severities. The query is too large to display on the screen, so it will be broken into 3 parts for display purposes. This is the top of the with clause. All alarm fields referenced in the previous slide are here. As discussed previously, the regex_replace removes extra spaces from the description and log message fields. Joins on the node and service tables are completed here. All that remains from the previous slide is the conversion of the alarm type and severity to understandable text and the extraction of the sticky and journal memos. Next, the arrays for alarm type and severity are created. The sticky memo is retrieved using the alarm's sticky memo value. The journal memo is retrieved using the alarm's reduction key value. Fields retrieved from the memos table record are author, updated or created time, and body. regex_replace is used to remove extra spaces from the memos record body field value. Finally, the select clause demonstrates the use of the arrays alarm type and severity, using as indices the values from the alarms table alarm type and severity, respectively. The severity is converted to uppercase. The sticky and journal memos author/date combination is retrieved as a single string. T-ticket ID and T-ticket state are retrieved for future use. Run the SQL script from within PSQL using \i pg.sql. Now, run it from the command line and store the output. The command is psql-u opennms.127.0.0.1-f var ephemera pg.sql and redirect that into z before resolving sshd. Again, the file name is z_before_resolving_sshd. Cat the output file and view the results. Restart sshd using the command system control restart sshd. Check the status using system control status sshd. Note the uptime 1417. Return to the localhost front page in OpenNMS and click on the Service is Restored event number 206. Click on that event number. The event time is 1418, about a minute after the service actually restarted. Note the log message. The SSH outage on interface 127.0.0.1 has been cleared. Service is restored. Note the description also references the service restoration. Click on Status Notifications, All Acknowledged Notifications. Recall that the original notification was number 36. Click on ID 36. The users notified indicate that a last notification was made at 1418. Return to the terminals, first as root, and check the email using mailx. The resolved issue for notice number 36 is in root's mail. Click on the message to read it. Quit reading mail as root. Do the same thing for def user. The resolved issue for notice number 36 is in def user's mail. Click on the message to read it. Quit reading mail as def user. Jump to PSQL and run /i pg.sql. Note the alarm type of resolving and the severity of cleared. The log message has changed to that which is associated with the node service regained event. Also note that the alarm is not acknowledged. Run pg.sql from the command line, outputting the results to a file. In this case, the file name is z_after_resolving_sshd. Run a diff between the before and after files. The alarm type has changed from problem to resolving. The initiating event number 203 had a minor severity, and the resolving event number 206 produced a cleared severity in the alarm. Finally, note the alarm log message changed to that of the resolving event. The OpenNMS alarm lifetime rules are: if the alarm severity is cleared and the alarm is unacknowledged, delete the alarm after 5 minutes. If the alarm severity is cleared and the alarm is acknowledged, delete the alarm after 1 day. If the alarm is active and the alarm is unacknowledged, delete the alarm after 3 days. All other alarms are deleted after 8 days. These delays are based on the last event time and will restart the counter if a new problem event is reduced into the same alarm. Note the severity is cleared and the alarm remains unacknowledged. The last event time is 1418. According to the alarm lifetime rules, the alarm will be deleted from the database after 1423. Check the alarm using pg.sql. There is nothing displayed. Check for any alarms using select asterisk from alarms. There is nothing. Check for any memos using select asterisk from memos. All that remains is the journal memo tied to the reduction key for node lost service. To summarize, one or more events can be aggregated into a single alarm if the event class definition contains the alarm data element with the alarm type set equal to 1, which indicates a problem. The events are aggregated based on the reduction key. The reduction key for the sample element is shown in the slide. Elements with alarm type 2 indicate a resolution to the alarm with a reduction key that matches the clear key attribute of the event. All alarms have a life cycle. An SQL statement was created to display alarm attribute values. That script, pg.sql, was executed at various points of the demo Alarms lifecycle. Coming up, Module 5 continues with Part C, Lifecycle Rules and something called drools.